Now to use Minsky to build a basic economic model, again one I could do in Simulink or VisSim. The real treat comes when I show what I can do with a banking icon, which none of the other programs have. Let's start by defining GDP, or gross domestic product, or output, which is a standard variable in any macroeconomic model, of course. I'm not going to give it a value here because it's determined by the dynamics of the system further on. So we have GDP, and I now divide that by, I'm going to call it lab prod for labour productivity, and give that a value of 2, meaning that each worker can produce 2 units of output. So we now have labour productivity here. If I divide labour productivity into GDP, I'm then going to have the number of workers employed. I'll call it workforce. And then if I then divide workforce by population, and for the sake of a fast demonstration I'll use a constant population here, call it pop, and give that a value of say 55 and 55 million for, let's say we're talking England here. Alright, now let's wire those little bits up. So I'm now saying that GDP divided by labour productivity determines the workforce, and I then need another divide by block here, and divide workforce by population. Of course you then have the employment rate. So we now create another variable, we'll call it emp rate, and now I'm going to channel Milton Friedman here and bring in what Milton once called the non-accelerating inflation rate, but I'm going to make the rate of employment, and say that let's just assume, as Milton Friedman did, that there's some rate of employment at which there's a tendency for the rate of inflation to neither increase nor decrease. So I'm going to bring that in here and say that's NAIRE, N-A-I-R-E, or non-accelerating inflation rate of employment. Might sound a bit like gobbledygook to non-economists. It is gobbledygook, but I'm just going to put it in here and show how it doesn't quite behave the way that statically oriented economists believe it would do. So then what I'm now going to do is say, okay, first of all we have workforce divided by population as the employment rate, and then if I subtract the NAIRE from the actual employment rate, I then have whether there's a tendency for wages to rise or fall. So if actual employment exceeds NAIRE, there's a tendency for wages to rise. If it's below, a tendency to fall. And the simplest way to model that is to presume they have a linear tendency. So I'm going to say employment, let's say wage reaction, let's call this, and give that a value of say 10. And what that's arguing that if, for example, there's a 1% gap between the employment rate and the NAIRE, then the wage reaction will be 10 times that size. So if there's employment is 1% higher than that rate, workers will demand a 10% wage increase, that sort of thing. So I need to multiply that wage reaction by the gap, and I've then got the rate of change of wages with respect to time at this stage. That's the response that workers will make. So I now need to work out what the wage is. And this is where we bring down the idea of an integral block again, because the wage is a response to dynamic pressures. And if I now say this is actually the wage rate, so I right click and choose edit and rename that variable to the wage rate, and let's give that a value of 1.8, let's say. So each worker receives 1.8 units of output per annum. Now again, as I showed you the population equation in the earlier model, if I take the wage rate, multiply it by the reaction function, integrated, I get the actual wage rate. So I'm going to right click here, choose copy the variable, bring this over here, and then I now multiply the reaction function by the actual wage, integrate it, and I then have the wage at any point in time. So we now have the wage determined. With the wage rate, if I now multiply the wage rate by the workforce, so I can right click here and choose copy and bring this down to the bottom here, and I'm just going to turn right click and flip that around, so I now start developing a circuit. If I multiply the wage rate by the workforce, I'm going to get the wage bill. So I choose multiply block, bring that down here. Now I can wire these bits up, so let's do that. Bring the wage rate, so the wage rate multiplied by workforce is going to be the wage bill. Let's just make that a slightly less ugly wire, bend it around a bit. Now bring another variable called the wage bill, And now if I subtract, since now I've now got the wages, and this is a simple two-class system, so output minus the wage bill is profits, so I now need another variable which I'm going to call profit. And in the simple Goodwin model, all profits are invested. Of course, that can be changed later to make it more realistic, which I do in my Minsky models. Now, investment is the rate of change of capital stock. So I need another integral equation to say if you integrate investment and add it to the early level of capital, the original level of capital, you get the current level of capital stock. So let's edit this variable and call it capital, and give it an initial value of, say, 300. I now wire this up, and what have I left out? I've left out GDP. Let's go and get a copy of GDP. So right click, choose copy, bring that down here. So the wage bill minus GDP is going to be profit, so I need a minus key here as well. And then I can link the rest of that together, so let's just wire that up. So GDP minus the wage bill is profit. In the simple model, all profits invested. Investment is the rate of change of capital stock. Integrate it, you're at the current level of capital. The last thing I need now is a capital output ratio. I call it capital, let's just say COR for capital output ratio. And let's say that ratio is 3. So you need 3 units of capital to produce 1 unit of output. If I now divide capital output rate, capital by the capital output ratio, I will have the amount of output being produced, which closes the model, which is GDP. Let's wire that up. So capital output, capital divided by the capital output ratio is the level of GDP or output. Let's just drag that out a bit. And now let's just graph one of the elements here and see what happens. Bring down a chart here. Let's graph the wage rate. Right click and choose copy. Place it over here. Right click and flip it around so it points in the right direction. Get the wire out, connect the wire. I'm just going to check my initial value for the scale of the simulation here. I like having a low value for the maximum step size to make the function look smoother and run slightly more slowly when you're simulating it. Let's try 0.1. And you get cycles and wages. Let's take a look at the employment rate as well. Right click, choose the copy, bring that over here. Wire that up. Cycles in the same thing. Bring down another chart and let's just get a bit lazy here and just wire from one output to the other over there and label down to the same point on the x-axis there. Let's now just drag this around a bit. So you can see the similarity of this model to the predator-prey model, but in fact it's derived from a structural, incredibly simple, but a structural model of the economy. Okay, you could do that with any of the other programs. Let's now take a look at things you can't do so easily with them, which is model a financial system.